Alright, in this video I'd like to talk about interval notation and set notation. Alright, so we are already familiar with, say, the notation, x is less than 3. Alright, so we can graph it on a number line by simply saying, alright, here's 3. Alright. And we say, alright, we're going to shade to the left, right, because we want all numbers that are less than 3, so we shade out here to the left. Put a little arrow to note that it keeps going forever. And then we say, is the number 3 included or not included in the solution of this? Well, since x is less than 3, 3 is not included, and so we would use like an open circle or a parenthesis from a previous video. So I'm going to go ahead and use a parenthesis, right, since it's not included. So it look like such. But you could also have used an open circle, right, as opposed to, say, this one where we have, say, x is greater than 3. Alright, here's 3. And we want to shade out to the right this time because we want all numbers that are larger than 3. Put arrow on the end again. And this time, since 3 is included, we would use like a closed circle, a little dot, or a bracket. And I'm going to use a bracket, closed bracket, like that. Alright, so that would be the graphical representation of these two notations over here, right? The new notation I want to talk about is interval notation. All right, so interval notation, we want to literally write the interval that represents all the numbers that are solutions to a particular inequality, like this one. So over here on the graph, this shaded stuff that we do, that's actually the interval, right? That's an interval. All numbers in this shaded area here make this true. So to do the interval notation, we want to look for the smallest number. Well, since this first one here, it goes out forever, towards negative infinity. We say negative infinity being the smallest number in our interval, even though you never get to infinity. And then we have a comma, and then what's the largest number in our interval? In this case, we get to 3. Now we don't really get to 3, right? Because 3 is not included. We can't put the first number to the left of 3 because we can get infinitely close to 3. All right, so what we do is we plot the two numbers for our interval, right? The smallest to the largest, so smallest on the left, largest on the right, and then we say, all right, is the number 3 included or not included in the solution? Well, it's not included. So just like we did on the graph here, we're going to have a parenthesis. And then infinity, whether it's positive or negative, it is never included, so it will always be a parenthesis. All right, there'll always be a parenthesis when we are messing with infinity. And then down here on this second one here, we got the smallest number is 3, over here, and then it goes out to positive infinity on the right, right? This would be the interval. And since 3 is included, we'd put a bracket, just like we did on the number line. And then infinity is not included, so we would put a parenthesis. And these two things right here, this represents the interval of this graph and this particular algebraic notation over here on the left. Right? So this is called interval notation. There are some variations of it. So for this next one, let's say we've got this expression. Negative 2 is less than or equal to x is less than 5. Right? So we've got negative 2 on our number line we can plot and 5 on our number line that we can plot. All right? And this is saying that our values that we're looking for have to be greater than negative 2, but at the same time they have to be less than 5. Everybody see that? That's really what this compact expression is saying. Really, another way to put that in English is all numbers that are between negative 2 and 5, right? So greater than negative 2, but at the same time less than 5 would be all numbers between negative 2 and 5, and we would just shade that part right there. And then we would determine the endpoints of the interval. For example, negative 2 here is included because it's equal to, so we would have a bracket. And 5 is not included, so we would have a parenthesis. Right? And then interval notation would look just like that. You have a bracket, negative 2, comma, 5, parenthesis. Right? Interval notation. One more I want to do on interval notation, and then we'll briefly go through the set notation. All right. So what if we have it looking like this? This is called these last two here are called compound inequalities. You'll see somewhere down the road. So here we're looking for all numbers that are solutions to this first inequality, x is less than or equal to -2, or any numbers that are solutions to the second inequality, x is greater than 5. All right. So again, we've got the -2 and 5 that we can plot on our number line, and then we look at, all right, since it's an or, we're looking for all the numbers that make either one of these true, right? So x is less than or equal to -2. Well, that would mean we'd shade out to the left here, less than -2. And since -2 is included, you'd have a bracket like such. And then for the second one, all numbers are greater than 5, so we'd shade out to the right here of 5, put a little arrow on, say it goes on forever. And then 5 is not included, so we'd put a parenthesis. Right? So that's what the graphical representation would look like for an algebraic solution such as this, with an or, typically with an or. Interval notation would look very similar. We've got two intervals though, right? As opposed to these first three examples, we had one interval. Now we have two. So we just do them both. So this first interval would have -infinity to -2 included. Then we would have the second interval, parenthesis 5 to infinity. And what we do is we use this u in between them, like this, a u without a tail, I call it, for the word union. And really that's the mathematical version of the word or, right? So this down here would be read, any number in this interval, -infinity to -2, so any number less than -2, or, that's what the union means, any number greater than 5. Right? So this is what the interval notation would look like, which is a little bit different. So whenever you want to join intervals with an or, then we use this u without a tail. All right? Okay, so that's interval notation. Set notation uses the squiggly braces, right? And it's whatever letter you're playing with. So in this case, we're playing with x. And then there's this vertical bar. Now that vertical bar means such that, right? So write that down. This vertical bar means such that. So we read this at the moment as all x's such that, well, such that what happens? Well, back here on the algebraic expression, such that x is less than 3. So this right here is called set notation. Right? We read all x's such that x is less than 3, which means that any number less than 3 are the numbers that we want for the solution. Right? So same idea down here. We'd have all x's such that x is greater than or equal to 3. For the third one down here, we'd have all x's such that x is between -2 and 5. Right? And then for this last one, we would have all x's such that x is less than -2 or x is greater than 5. So if you already have the algebraic solution, then writing it in set notation is pretty easy. You just throw in a little x such that, or I should say whatever variable you're playing with. It might not be x that you're playing with. The new thing here is really the interval notation, and you should know how to use all four of these notations and be able to go between all four of these notations. So if you see x is less than 3, we know, hey, that means -infinity, 3 in interval notation, which also means, hey, all x is such that x is less than 3 in set notation. You want to be able to go between all four of them fairly easily. All right? All right, that's it. Study well. Please let me know if you have any questions.